is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
There we go. Welcome everybody to the Sunday night call. I got the recording started. Tonight, very excited about this. I've been asking on almost every call, certainly on every email that goes out for teams to sign up to do a get to know our team. And tonight we have team 2847 MegaHertz are going to give us a rundown of their team. I will let you guys take it from here and do your introductions and share who you are and what your role is on the team. The floor is yours. Go ahead. Before we start, how do you want to do questions? Do you want people to interrupt throughout or wait till the end?
Yeah, please interrupt as soon as you have something you want to ask about. Go for it, and we'll dive into it. And if there's something you're like, oh man, that's not enough detail, more detail, we'll go deeper in any topic. So,
all right. Well, there you go. Take it away.
Cool. Well, just I'll do introductions here. So I'm Sam Wieselman, one of the lead mentors here, and our other lead mentor, Aaron Perkins, is on.
Hello.
And then we have our two team captains, Isaac Stone and Sam Grogan, here as well to present. So just high level agenda here. We're just go over our team a little bit, kind of show our shop space and what we're working with, and then just kind of how we approach the build season, what our build season schedule is like. Some technical stuff that we do that we think is pretty cool. So those are all going to be kind of high level and things we're excited about, but definitely willing to dive deeper into. And then an overview of kind of our outreach and advocacy we do. So yeah, we'll get right into it. So team overview, we are from Fairmont High School. We're about 7 miles away from the Iowa border, but we are Minnesota. So don't get the wires crossed there. We're very proud of that still. We're about 24 students and 11 mentors. 3 of the mentors on the team are alumni. We switched out. The team was started in 2009 by a CTE teacher. I was on not the first team, but the second team, or the second year that it was a team, went to college, came back, and then eventually became the lead mentor in 2018. And then in 2025, through some unfortunate circumstances, the Mighty Morphin Banana Slugs down the road from Laverne ended up closing the doors on their team, and we welcomed as a new co-lead mentor Aaron Perkins, kind of merging the teams together, bringing in some of the students from Laverne, and did a kind of a blended build, outreach, and some branding too. So that's kind of a high level there. So just kind of wanted to highlight, especially for the students on this call, we've kind of been building up the team year after year, and really it's been a lot of the team leads learning things the hard way and passing it on to the next generation of students. And those students who are freshmen and sophomore, watching how the juniors and seniors act and kind of following through or following up on that, building on top of that, and building on the knowledge, success, and the resources that those previous team leaders acquired. And so just starting out in 2018, we were ranked 58 at our only regional. We'd only won 1 award in our team history. We were ranked 58, but we deserved to be 61st. It was not good. The next year, we kind of climbed up to rank 21. The year after that, we ranked really poorly, but we did end up in playoffs. So we've kind of been building up slowly year after year. Each group of students passing on to the one before, building up team resources, knowledge, and all of those things. And so with that, I'll hand it off to our team captain, who's Sam Grogan here.
So 2022 was my first year as a freshman, and I didn't realize it at the time, but we were kind of making history as our team. At Duluth, we were finalists, and we placed high enough to qualify for state for the first time as Fairmont. And then the following year, we continued to do well. We were second place Alliance captains again in 23, and it qualified us for Worlds through a wild card. So we ended up going to Worlds for the first time, and then we ended up winning state for the first time. 2024 was a kind of a rough patch for us. We're still kind of going off the high of winning state. And so our mindset was that we were going to be the best bot in the world and try to like do everything that the game had to offer. And it kind of ended up hurting us as there was a bunch of minor details that we didn't really get worked out. So then after that year, this year, we kind of taken a step back and kind of like examine what we can and can't do, and that it's okay to have a simple robot. And so far it's been working, because in Duluth we ended up placing first for the first time in school history, and even winning the double decker match. So next slide. So our space that we've been using has really evolved throughout the years. In 2022, we were sharing a room with another class, and it was very annoying because it'd be every day when we come in, the first thing we'd have to do is move all the desks to one corner, and we had to fit all of our tools, our practice field, and everything into the back of the room, and then bring it out. And at the end of every night, we'd have to bring the desks back, move everything back, and it was very tedious. And if you remember, 2022 involved shooting the balls into a very high game element. So how we achieved that was going into one of our stairwells and shooting the balls up there to see if we get that height. The following year, though, next slide. The following year, after we did pretty well, we were able to take over the old wood shop from the woods teacher, and we were able to move all of our stuff in there. So we got our own closet, which was very nice, because then we didn't have to worry about a bunch of high schoolers messing around with our tools and our robots and all that. And then we were also able to lay out our game elements, or the field elements, and keep them there so that we didn't have to constantly be moving them around. And it's especially good for this year because the charging station was very heavy. So if you go to the next slide, we also, the 2024, got the classroom above us, and we were able to use our practice field, put our practice field there instead. Obviously it's this 2025 field, but as you can see, it's like slightly thinner than the real field. So we kind of have to work around that with just practicing autos on one side, and then when we need to, have to move everything over. 2024, we were only able to use autos on the non-amp side, and this year we've been able to move the reef back and forth to practice on autos on either side. Next slide. So then it was the fall before the 2024 season. We worked on getting a grant to buy a bunch of more equipment for us. So in the top left, you can see we were able to afford a laser cutter and metal saw. And then we were able to afford new toolboxes. And on the bottom, we were able to afford a couple more CNC routers and a CNC router and a mill. Because originally on the right of that bottom image, we had to use that, and it was very annoying because it was very loud and it had a lot of problems with it. And so like every time we wanted to use it, we had to use it during lunch and have everybody leave the room. So it's really nice this year being able to cut out metal without having to have everyone leave the room with our router. That's a lot more quiet. So if you go to the next slide, we were also able to renovate our office into our kind of programming and designer room. On the right side, you can see we have 3 printers, which we upgraded from one. Like we had 1, and then now we have 3, which has been nice because we're able to print a lot of stuff a lot more quicker. And we have a lot of computers that we're able to design and program on, and without having to listen to all the tools going on outside. Next slide. And then we also wanted to kind of just replicate what our field or what our pit will look like. So on that left image, you can kind of see that's what our pit looks like in a real competition. And we wanted to do this so then kids get the feel for searching for tools, especially if it has to be a quick fix. And with getting a couple more toolboxes, obviously like the layout changed. So we need to get used to that as well. Go to the next slide. So this year
I
we
was going to say, oh, sorry, Sam. I was going to just inject a pause for questions or anything. I don't know if anyone has anything they wanted to ask about. Yeah, just go ahead and speak. Yeah, you got it.
I guess I was wondering, how did you go about advocating for like the larger space? I know after 2022 you moved into a larger space. How did you go about sort of advocating for that? Was that something you had to really push for? Was it something sort of the school said, we have this open room?
Right. So we kind of did get a little lucky. The school was making this like $1 million building extension to the school, and that's where all the CTE stuff went. So including the new woods room. So then it was an open room for us to take, and that's kind of like the same thing with upstairs. It was just an open classroom that we were able to take. Any other questions? All right. So for this year, like I said before, 2024 kind of scarred us. We realized that we can't do everything. We had to understand what we had and what we could achieve. Like right now, we have one programmer and then a couple designers. So we knew we couldn't do some elaborate robot design and not like do crazy code. So we just wanted to keep things simple this year, and we agreed at the beginning of the year that we weren't going to try to achieve everything. Go to the next slide. So our other thought process was that we can't, like, part of being a simple robot design was that we didn't want to do more new things. So in 23, that's our first year using swerve and an arm. So kind of had to mess with that. And then 24, we were using a full field localization and automated shooting. And then this year was our first year using an elevator and working towards allocating all the controls to one controller for the driver. Our other goal was to make sure we hit home with all of our new concepts. So like over the summer for our elevator, we were kind of planning on maybe using an elevator because we saw there's been a lot of elevator usage. So we built one over the summer and did some programming with that. And we got pretty lucky because this year requires a lot of elevators. So it's pretty nice we had that, and we were able to mess with that at the, like, right as kickoff went on. Our other goal was to make sure we were able to get those mechanisms to programmers. So our swerve drive was in 23 was built by week 1, so we were able to hand it off to them, and our arm was built by week 3. For our field localization, we put the limelight on the drive base at the end of week 1, and then for this year, our elevator was made by week 2. So next slide. So our big goal for our schedule is just do it as fast as possible. So by week 1, we wanted our robot architecture done and including everything we would and wouldn't do. So like what levels we'd score on, if we pick up from the ground, all that kind of stuff. And then from there, we were able to design it all and start building prototypes. We wanted our final CAD done by week 3 and our drive base to be built completely so we could start wiring it. And we had our final robot done week 4. So then after that, we were able to keep iterating and handing it off to programmers as well. So then they can mess with it as well. And then this year was our first year that we were able to do, or not first year, but it's been a few years since we've been able to compete at a week 1, mostly because we didn't want to, or just because we weren't ready, or week 0, sorry. So we were able to accomplish that this year as well. Next slide. So with prototyping, our laser engraver really helped us a lot because we were able to pump out prototypes really quickly. And another thing that was pretty huge for our team this year was that it's been the first year that we were able to manufacture everything in-house. We usually had a sponsor local produce all of the metal parts once we get the CAD done, but this year we were able to make it all as we kept going. And like I said before, the elevator really helped us with prototyping because we were able to see how high up we needed our coral shooter to be in order to reach the L4 and still shoot well on it. And we also used the elevator to kind of test out our deep climb. Next slide. And so this was part of our architecture thing. We got our simplified robot model done by week 1, the one on the left, pretty much the top one. That's kind of when we decided that we'd have 3 subsystems lined up, each for each task. And then on the bottom was kind of just like us deciding on where we'd like to orientate it. Like if we want the elevator on the back with the climber right next to it, or all that kind of stuff. And then on the right is our final robot design. And then, yeah, I'll let you take it away now, Stone.
All right, thanks, Sam. So at the start of each build season, we split up our team into however many subsystems we need. And every subsystem is led by a student depending on their interests, their skills, their experience, and how many hours they've spent in the shop over the summer and over the past years. On each subsystem, there's also a mentor that's usually had some experience working with that type of subsystem before to guide them. The point of this is to split up the work among our team members so we can get stuff done more efficiently and so that everybody gets a chance to work on the robot. Another big thing this year was wiring. Last year, we had a ton of wiring failures. That really hurt us last year. So this year, our design team made a lot of stress reliefs for our wires. You can see a few of those. We hot glued any little wires so they don't pull out. Everything's soldered. I don't think we have a single Wago in our robot right now. You always grab somebody else to go pull on your solder to make sure you did it good. If you can, always put wires in sheaths so they don't get frayed. And this year, we had a few people put 4-gauge wire onto all of our batteries. And on the left here, you can see a few strain relief prints on a Robo Rio, and on the right, you can kind of see it through the polycarb. It's an okay picture. Programming and software. This year was our first year using Advantage Kit and Advantage Scope. Simulation has been huge for us this year. It's allowed our programmers to test stuff without using the robot, which allows the build team to keep working and just get more stuff done. Another big part of it is logging. So if something goes wrong, instead of trying to get it to happen again and just taking a guess what happens, you can log different functions of your robot, and you can identify that issue pretty much immediately. That was a huge part of our autonomous this year, because initially after Duluth, we realized that we were asking our drivetrain to accelerate about 2 meters a second faster than it was able to. And so that was killing our autos as we tried to go faster. But then after a quick catch in Advantage Scope, we tuned that back in, and now everything's running pretty smooth. Perkins, you got it from here?
I guess before we hit that, does anybody have any questions on simulations or anything like that? Want to see a simulation, a demo, anything along those lines? Okay. Okay. So flashy sign is so I remember that I'm supposed to speak here. I'm going to talk about advocacy a little bit in our outreach efforts. Next slide. So right now this year, we have 2 bills in the works. One, we had a Senate hearing the Monday after Duluth for SF 1726. It's in conjunction with High Tech Kids and Emily Sade of the STEM ecosystem. And then last week on Thursday, we had the House hearing for it. And that's conjunction not only with us, but also Gear Wizards. And yes, this bill isn't going to have a direct effect on FRC funding in any way, shape, or form, but it does get us that STEM pipeline that we desperately need, all teams need. So hopefully down the road, we can get more kids into robotics. Next slide, please. The other one we're working on is the XRP in classrooms bill. We chose to go with the STEM ecosystem bill this year, mainly so we're not flooding, robotics throughout the Senate and House. We're going to look at this one probably next year or the year after. Wait for the political climate for more funding to become available, honestly. We've worked with DECA, FIRST, and P20, the Minnesota Department of Education on this. We'll be presenting at Worlds also that Friday, I believe it is, 4 o'clock on this with DECA and FIRST. And really, this is something that should benefit us all down the road, FTC and FRC, working with these bots. You can make, and I actually built a couple Mecum Drive and also Swerve Drive bots using these. So you can teach kids coding and all that sort of stuff. So we're hoping to get this one soon. The other things we've done, we have, question.
I guess I was wondering how much of the bill writing and advocacy work is coming from students versus mentors, because that's something I've been thinking a lot about. I'm interning at the Capitol right now, into thinking about what sort of how much of that work is done by students.
Okay, so the high-tech kids bill, the bill writing itself, most bill writing is not done by students. The high-tech kids bill, that one was more or less, we started our conversations with Emily Sade last year on this. And realistically, that's a high-tech kids bill. They're pretty much just funneling it. We know it's there, so we just go and we hit up all the senators and representatives we can. And we've done testimony and that sort of stuff for the House and Senate. The XRP bill, on the other hand, that bill is actually being written by Steve Smith from Experiential Consulting in DC. I believe he is FIRST lobbyist, I think is who it is. Honestly, this is all student. The XRP one is all student. I am not on the food chain. I'm not on the email chains. I've got nothing, honestly, to do with it. It's all kids. So it's also a case that you have to know somewhat the political climate on what the appetite is. I know that RoboHawks have a bill also that has one author in the Senate and the House, I believe it is. They're trying to go through education and not to put a kibosh on it, but there's no money in education. Not that there's any money anywhere right now in any government agency, but there's definitely nothing in education. The STEM ecosystem bill is going through the DEEDS, Department of Economic Development, basically. As far as the XRP bill, we were looking at either DEEDS or going through EGG, oddly enough, for that one. The EGG one, we've actually written and designed attachments for it to mimic EGG machinery. So if we can get into FFA and those type of classrooms and get that support, then it makes it easier. So as far as advocacy goes, I'll be honest with you, I've done a lot of it in the past, or I don't want to say I've done it. It's not me. I'm just kind of the guy in the room, the old guy in the room that makes people, look at them. But I really don't do any of it. It's all the kids. So, and you just have to have the desire and motivation to do it. And it's not easy, and you get a lot of no's. You get an awful lot of no's, a ridiculous amount of no's. But eventually get the yes. Hopefully that answers your question. Okay, next slide. First events. So this year we've worked 4 FLO and FTC events, and pretty much the ones in South Dakota can't be run without our support and the student support. We probably furnish half the volunteers in the South Dakota events right now for those for FLO. We've also worked to bolster FLO within South Dakota. We've done several open houses and to try and get FLL teams started. But pretty much the western edge of the state, we supply half of the volunteers to most of the events just so they can keep going. Next slide. And then, of course, we mentor and fund teams. So this year, the students have actively mentored 3 Vex teams, 2 FLL, and 1 FTC teams. And when I say that, it's not a case of, just one and done. They're pretty much the adults in the room, as wild as that is to say. There are other adults in the room to make sure no one loses a finger. But pretty much it's the kids running the show and teaching everything they know. Plus, we do also mentor 22 non-competitive Vex teams. We assist a slew of other teams financially and through other supports in southwestern Minnesota and South Dakota. We actually have 2 nonprofits. One is specifically for Martin County, and then the other one is for the western part of the state and South Dakota. And that, I think, is all we have. If there's any questions or comments or concerns, go for it.
I feel like I'm asking a lot of questions, but I was wondering, with your FLL and FTC teams, one thing that our team has really struggled with is making FRC students have enough time and actually interested in mentoring the team. So how do you go about having FRC students sign up to mentor these teams?
Okay, so there's a couple ways of doing this. The first thing is, if your school has an FCCLA program, Future Child Care Leaders of America, recruit those kids. Honestly, that's the easiest way to get kids to mentor. So if you recruit the kids specifically to mentor those kids, it helps. And it's weird to say that you're recruiting specifically for that function, but you recruit them for that function, then you teach them how to do everything, and then you turn them loose. And that's honestly, when I was with the Slugs, and even now, very similar situation. We're recruiting kids specifically that want to work with younger kids, that want to be teachers, that want to go into education, and recruiting those kids to then get that feel for what it's like to work with the elementary school kids. And it's not necessarily, I've talked to other teams, and they often, you have the perfectly valid question, because how do you get it to work? That's how you work. You recruit the kids specifically for those functions. And then, they still touch the bot. They still go to the competitions. They understand stuff. You rope them in other ways too. But I would not necessarily expect Sam and Isaac here to spend all their days mentoring those guys. You have to find the other people specifically that want to do it and that have the skill set to do it. Because not everyone on the team can or should. Some just are not good with younger kids.
I'm gonna ask the same question, but about adults. How do you adults have the time for that? I know that's maybe that's a lame same question, but
so it's tricky. So when I look at these numbers, those are shrunk from last year. Honestly, I think between the two of us, if you look at our individual teams before we combined them, we probably had 3 or 4 times that number. I think I had 12 in Laverne last year. But it really comes down to, yes, I was the adult in the room, and yes, there are adults in the room, but it's really finding those responsible kids that can handle it. For the past 3 years, I didn't know any of the elementary school kids' names. It's cold and callous to say that. I didn't know their names. I was the adult in the room, making sure that no one got hurt, but and I had the time after school to do it while other things were going on in the shop. Honestly, the main issue, it's not even so much adult space, it's shop space and workspace. I know the Laverne groups that I still have going out there, they're meeting on Sundays now because that's what works best for FLL. And it works best for the kids. And then I've just found if the kids wanted to be in it this year, the parents had to be involved because I couldn't be there all the time. So, and the same with FTC. If the kids want to be in, we need a parent to step up and do it. Otherwise, it's just not happening. I know that's the same with the Vex teams too, the 22 non-competitive Vex teams and the Vex IQ teams, we need at least one parent there because there's just not enough adults, as bad as that is to say. Now, if it's absolutely there are no adults, will we figure out a way to make it happen? Sure. I have sucker written on my forehead. It's okay and gullible. But it's one of those things that's always the first thing. And, you know, if you charge a fee, you say, hey, guess what? Your fee is gone if you're going to help with the program.
I guess I'll build on that too, is like, at least with my experience too, is like trying to watch how some of the other like activities in your area do it. Like a lot of your football, like let's say football, right? They'll have a high school football team, junior high, middle school, all the way down, right? And it's not the head football coach at all of those things. And so like really my experience was like spinning it up was very hard, but once you got a couple more adults bought in, or even just at the level, adults or responsible kids or some blend of it, right? Like an adult to unlock the room and students to show up and teach the robots, let's say. I mean, that's kind of some of our model, at least. Yeah, I kind of trailing off there. It's hard to start, but if you can get a couple more people bought in, it really gets that flywheel going. And then, I mean, I know this last year, at least with the Vex teams we had, it got to the point where like, okay, we qualified for Worlds. Like we do not have time to like help with the spring stuff as much as we had wanted to or would have in past years. And honestly, the people who are running the program didn't want to see it shut down or shrink, and they stepped up to do it. And so it's kind of a hard plunge for everybody, honestly. Once the flywheel's spinning, kind of wants to keep spinning. So hopefully that's generic enough. I don't know.
And that is a very true statement. I mean, once you get a couple of those, and you often hear from parents, well, I don't know anything about coding. Guess what? For FLL and FTC, the kids will figure it out. You don't have to. You just have to be the adult in the room, really, and make sure that they don't fight and aren't, you know, harassing each other. Really is what it is, as far as the parent help. It's not bad. FTC is pretty easy too, really, to learn to code. Block coding is easy. I think, you know, for the FLL, we always started to do some structured activities, teamwork, that sort of stuff. But the actual coding and bot, the kids can figure it out. They like playing with Legos and erector sets, even though they don't know what an erector set is. They still like it. So, yeah.
Can you guys talk a little bit about your general recruiting for the team? I'm not even sure how big your town is, how big your high schools are. And then I know that you combine schools. How far apart are the schools, and how does that work across the two schools?
Okay, so as far as recruiting goes, there wasn't, up until this year, there was no one in the school. So I'm the first team person in the school. So I don't really know how recruiting was done previously to this year. I'm guessing it was a lot of word of mouth and things like that. Would you agree with that, guys?
Yeah, and like as students, like we'd always like try to like scope out friends or just people we see and like try to convince them to join, but it's always been a pretty big struggle. And you know, we try doing like open houses and like recruitment meetings with like anyone who's interested to join, but it's always been a pretty big struggle for us to recruit teams or team members. And one of the biggest struggles, or like something that doesn't help us, is that we don't really have any engineering classes in our school. It's mostly trades, so like welding and woodworking, like we have those, but we don't have any design or programming classes offered.
So from here, looking at next year, I'm working on slowly building up and recruiting people within the school. So I'm looking at the kids that have advocacy skills, outreach skills, those sort of things. I'm also looking at the ones that I teach science, so physics, chemistry, math. So I'm looking at the kids that have some aptitude in there. I'm hoping to start teaching computer science in the next 2 years, and that will help with that too. As far as the combining team goes, it's 88 miles apart. So Saturdays. Basically, it's Saturdays, or if we're doing advocacy and outreach stuff, it's pretty much over a Zoom meeting. Monday, basically, when we were doing impact stuff, it was pretty much every night we were meeting for an hour or two over Zoom. And then Saturdays, they would drive out here. A family, or I would drive out there, get them, and then bring them back. So that was most of it. Now, we've gone to the Capitol a couple times, and even for competitions, the kids are coming out here to Fairmont. They're driving that 88 miles, and then we're going from there. It hasn't been easy from anybody, any standpoint. It hasn't. And we pretty much, for the most part, just kept the juniors and seniors. If underclassmen, sadly, the feasibility of getting them out here becomes more difficult. As much as I hate to say it, but we had FTC teams out there, so we kind of funneled them into that. So they still are getting the robotics experience. They're still getting the same basic skill set. They're just not getting the full FRC experience. And it wasn't feasible out there to do that for the younger kids. So that was kind of the compromise we came up with, was basically me traveling a lot, which isn't much of a compromise, but it's what we did. Hopefully that answers your question. But yeah, it hasn't been easy. I'm not going to lie and say it has been easy. It has not. I think that the Laverne kids have learned a lot about how to build a robot, because anybody that knows my former team, we could not build a robot to save our life. We could slap metal together and hope for the best, and we had fun and we were goofy. But we were really good at advocacy stuff and outreach stuff and working with younger kids and that sort of thing. So working with the Fairmont group to teach them those skills has been good for both sides, honestly. The kids that want to learn to build, they've learned how to build better. And from the Laverne group and then the Fairmont group, the advocacy and things like that they've never gotten to do, it's helped them. Any other questions?
Can you guys share how you do things like captain selection, drive team selection, pit crew? Is that what is your process for finding student leaders?
We mostly go off of hours and kind of skills put in. This is my second year as a captain, and kind of started off with me just putting a lot of time and effort into the team, working on stuff outside. Like I was one of the people that helped get that grant going for us to afford all of the new machinery in our shop. So yeah, I'd say mostly it's drive team, or it's mostly hours that contributes to all those roles. So then like for drive team, I'm the driver, and then Stone, he is also the driver. And just going down the list, it keeps going off based off of hours. So human player and our tech, they're like the second and third most hours, and so on.
From a mentor's point of view, I'll have the caveat of so hours is one of the ways we objectify it, but we're also not giving credit for unproductive hours, or not probably more lenient than we should be, but still like just not just being there, and then also really highly valuing like work outside of practice too. So if you're stuck on a code problem and you go home and you come back to next practice with it fixed, that's seen as a leadership trait, or a trait of somebody who's pretty bought in and ready to like work on things, versus a kind of student who's there and basically they check out the moment they leave and check in the second it shows back up, which is great. You need tons of people like that on the team, but maybe not for like a leadership role. And at least historically, I wouldn't say we've got an amazing process for it, but for captains, it's been filling out an application and then mentors reviewing who we think would be a good fit generally. Yeah.
And how many captains do you end up having every year?
So 2 to 3 overall team captains has been what we've been doing, just depending on the student. The other thing I think we've learned, at least as like a mentor group, and as our captains as we've gotten built out like our student leads more, and you guys can comment on this, is leaving any leadership role that should be, if a student's not ready for it, do not put them in it. It's better to leave it empty than to put the wrong person in the role. The student won't succeed, the team won't succeed. You're setting a student up for failure. It's not, and it'll happen from time to time, but I don't know if Sam and I give any comments on any of that, but.
Oh,
Yeah.
we completely agree with that.
Yeah.
So I'm very intrigued by the advocacy work that you're talking about, Aaron, and I feel like we could do an entire talk on that. Hint, maybe we should. But I'm curious to know how does that translate into like really intensive judging prep for pit judging and things like that? Do you have an entire process around that, or is it just sort of natural because your students are constantly thinking about how to advocate for their team?
So the Laverne kids, it's natural because they've grown up basically through the past 4 years doing it and of advocating. I will say the Fairmont group is getting better. It's something that has to be taught somewhat as far as that goes. But once they start getting it, it's not too bad to move forward. With advocacy overall, one of our kids is interning with SASA this year, or summer, I should say. The student advocacy, or whatever it is. Yeah, I always butcher the letters on that one, with SASA in DC. And he's done it for the past year. The kids that really, it's a confidence builder, honestly. So I don't like taking a student that has never talked to a politician or any of those things on their own, at least initially. I always try and do the buddy system, and then I kind of stand back in the corners and let them figure it out. And both Isaac and Sam this year went to the Capitol, January maybe? I don't remember where exactly it was. Sometime recently we went to the Capitol for the STEM ecosystem bill. And we took 2 of the Laverne kids, and they were not necessarily comfortable with it at first. I think it's safe to say for you two. But by the end, they kind of picked up how to handle it and how to talk to politicians and other groups and how to start advocating for meetings and really figure out how to get their foot in the door. Now, some of the kids have taken up a couple other times now up to the Capitol, and seeing the confidence grow there, it's definitely, once they get the confidence with the politicians, the judges are easy. Honestly, once you can get to the point where you can talk to adults and explain what robotics is and how it benefits them, talking to the judges and explaining the same thing to the judges is not that difficult. It's less intimidating because the judges want to hear from you. The politicians don't, at least not all of them. So it does help with judging in a lot of ways. And I hope, again, that answered somewhat your question. And I honestly don't know how it happened. So when I started in 2020 with robotics, I knew I couldn't build a robot. So we had to figure out some way to make our mark in the world that wasn't going to be robotics. So we went for all the other awards. And that's what we looked at because we couldn't build a robot. Now here, they can build robots. And so we're trying to flush out everything else. And I think we're getting there.
And then I'll throw in too, I do not nearly as much, but I know Sam and Isaac, we've worked a little bit on like the technical judging portion of the pit judging, especially, and like, on the controls and software side, just a little bit of coaching on like, you can reference them as motors. They don't know what a Kraken X60 is, or try to stay away from some of those buzzwords, meet the judges where they're at. You can turn the robot on and run it. That's okay. They like to see hands-on, things like that. And some bullet points. Also, a couple students on the team have put together a really, really cool engineering notebook too that really highlights a lot of the process. So that's another, like, having a visual and textual aid both for the judges and for the students presenting has been a total game changer, really.
And having that visual does help because then you have something to pull out for the judges and you're not necessarily floundering and you don't have to know everything then. So you can pull out that engineering notebook, that impact portfolio, whatever it is, whatever your documentation is, your business plan, and open it up and say, okay, so this is what we do. and just flip through it. And it gives the judges something to look at besides the student, which makes them feel a little more comfortable. And it also, then hopefully you can fill in holes. The main thing with any judging is when you're going through it, you want to make sure you eliminate any questions the judges may have. You want to try and beat the judges to their questions before they ask it. So eliminate all those possibilities so that then when they get down to it, they have nothing to ask because you've already answered all the questions they might have. And that's one of the things that we're really trying to drill down on, especially with the advocacy and impact stuff, is make sure you answer, when you answer a question, expand upon it enough that they don't have any follow-up questions to ask that you may not know.
I'm curious to know more about your robot. If we don't have any more things about the team, can we go back to your CAD image that you had of your robot? Can you explain more about the mechanisms in your robot and maybe that process you went? I know that you gave us the week 1, week 2, week 3, but maybe some of the iterations that you've done on this robot?
Yeah, so so to begin with, we kind of just thought about having a separate mechanism for each one. So we knew we could do an arm well, and we were kind of thinking, well, if we're gonna pick it up if we're gonna have to grab it from the reef and put it in the processor, it's probably gonna have to be an arm. And so we kind of messed around early on with like different compression and different shapes of the claw to see what works and what doesn't. And until we kind of figured out that we're compressing it by 4 inches and kind of bring it a little past the halfway point, I'm pretty sure, just so that we can secure it in. And what we brought to comp was, I think it was a 1-to-3 ratio on the algae, and it kept slipping out. And so now we've currently upped it to a 1-to-5 ratio. And so it really holds it in a lot better now. And I think also part of it was that it was always the top one. And I think it was like how we approached the algae. So like we now ram into the reef and then flip our arm over to grab it. Our coral is on an elevator, like we said before. And so originally we thought that L4 would have been too high, because we said before we kind of were worried about doing too much. So we originally thought that we would just do L3 and down and kind of call it there. But then as we were looking on Chief Delphi, I'm pretty sure it was Wild Stang's thread that they kind of mentioned that in autos you can really only do L4 because there's no L3 because they're all blocked by algae, and then half of the sides would be L2. And then finally our deep climb, that was our equivalent to the trap at the beginning. So right away we said we wouldn't, because originally it was like 3 inches. But then we started thinking about it more, and we were kind of thinking about how much more valuable it was from the trap. And so we decided that if we could design a prototype quickly, we would start considering it. So our team we kind of spent a late night at our own homes when we all left, trying to draw something up for a deep climb. And then as we got closer to it that night, we kind of realized it could have worked. And so, the design was something simple. So we would just press down on it and lift ourselves up, because we knew like if we were an inch or 2 above the ground, that would be good enough. And then, for our intake wise, that was kind of just like so we could reach L4, where we wanted to do the elevator in a 2-stage. And so we kind of thought like, okay, how much, like that's where we also prototyped was how high up we need to be from the reef or from the ground in order to reach that L4, and what angle we needed to be. So that was something we prototyped a lot. And so that's why our shooter is above the ground about 15 inches maybe. And then our intake is even more off the ground so we can intake it. That's pretty much it for our design. Is there anything specific?
So your climber pushes down through the center of your robot?
It actually doesn't. So we were thinking about that before if we needed to, but then as we were like, so like our belly pan hangs very low from our wheels. I think it's like an 1/8 or a 1/4 inch, and so that's how we're able to get it off. Like that's how we're able to just push down, so then the cage is squished against our belly pan with our foot, and we're only off like a couple inches, but it's enough for the judges to see, or the refs to see that we're off the ground. So
got it. But it is that sort of donut hole concept. You just don't have a hole. You just push down your bottom of your belly pan. Yeah. And then you have a static chute for human player intake, and the cage part that your coral goes into, that's what goes up and down the elevator, or does the chute also go up and down?
Yeah, so that chute stays in, like, that chute is attached statically down there. And, only the coral shooter goes up and down, the silver part.
Did you guys have to do anything with balancing weight to make sure you hang flat with such a shallow climb?
I think the only big thing, like, we honestly got, like, we knew right away that we'd have to kind of even the weight out. So that's also where our thought process came from, was elevator on the left side and arm on the right side. The only thing that we really did have to change was originally we were going to have our battery on the back of our like climb. So like the part you can't really see right now. But then like, as we were thinking about it, we're like thinking, well, the elevator is probably going to weigh more than that arm. So we should put the battery next to that arm. And so when we did that, our center of mass is like dead center, pretty much, probably just like a couple eighths off in either direction. And so that was really nice.
That's fantastic.
And you did most of that balancing in CAD first, correct, Sam?
Right. Yeah. So, constantly just putting it all in assembly, and then grabbing all the items and then seeing where the center of mass was. So that's that way when we were able to bring it out and build it all up, when we first climbed, we were very straight.
That's
I'm
great.
super impressed by how like lightweight your whole robot looks. It looks like it's on the Slim Fast diet. And we had weight issues all year. I mean, we were just battling. It felt like, or not year, 6 weeks. So anyway, I don't have a question, just a comment that it just looks so efficient and slim in a good way, in a really good way.
Well, it's kind of funny that you say it's light, because it's actually like 106 pounds, and that was kind of one of our worries, is we're like, because like CAD said it was like maybe like 90 something. I don't know. And then like 10 pounds for wiring and bolts and all that doesn't get accounted for. So we were actually a little worried when we built it all in like a couple weeks before, or like probably the week of comp. We were deciding, like, we were weighing it to make sure it was under 115. So, but we were. So
we weighed at Duluth, and the inspector looked at us and went, "Wow!" And we were 114.9. So so that's my context of like how close we were. So 106, I'm like, good. It's great. You got you got weight for days.
Feels like a lot lighter now, knowing. Were you guys like worried about that, like going in, or were you kind of just like
lots of sleepless nights.
Did you guys mess with the weight a lot, or like what did you all do to take off weight then?
We don't have like an official robot name, but we lovingly call it Cheese Ball, because we've Swiss cheesed all of the 2x1 as much as we could, other than the elevator, because we didn't want to take it apart again. Everything else is Swiss cheesed, with metal removed as much as possible. Okay. And then we did a lot of 3D printing. That was actually a nice forced thing for us. I see a lot on yours too, using all three of the ones you have. So. The 3D printing was a game changer as well for us. Like we started asking each other, like, does this have to be metal? And then we just swap it out. Like we were just like swapping everything out. So
yeah, I think something that helped us too is that all of our pulleys and gears are 3D printed, and not, or like the gears on the shooter and the arm are 3D printed, and so that also helps a lot with weight.
I am also very impressed with your weight. 106. I'd love to be at 106. That would make me very happy.
Seriously.
I think we went to our first competition. We were at 114 or 114.8, 114.6, something like that. No, we were at 114. It was either 8 or 9, and we weighed in and we lost almost 3/4 of a pound. So between our scale at school and the scale they used at competition, somehow we lost 3/4 of a pound. We recalibrated our scale again, but we used weight room weights. I mean, they're not anywhere near probably standard, but we used 5 different weights and they all came in at about the same amount. So our scale at school tells us that we're within probably 0.2 of a pound. And we are constantly trying to figure out how do we not add weight to the robot with all the changes that we've made. We've moved some of our plastic that we use to protect our wiring in bits and stop coral from getting stuck inside the chassis. We've added a hinge and screwed it to the bumpers because we have 2 pounds on the bumpers. So we've moved some of our plastic to the bumpers.
Okay.
But yeah, 106, that would be a nice weight to be at right now.
So I'm actually curious, how did you guys implement a ground intake into your robot, if you don't mind sharing?
It's real easy. You go out to Chief Delphi and you follow the Wild Stang build thread, and you take their ground intake, and then you figure out how to modify the design to work with your robot.
All right.
If you go out and look at the Wild Stang ground intake, it'll look very similar to what Nightcrawler has. We obviously had to change a few geometries. We found some things that we felt like places of coral would get stuck, so that we had to change a few things here and there. But 100% inspiration came from the open build log thread that they have. It's been working pretty well. Honestly, one of the things that we're probably a nice surprise by it is that ground intake scores L1 beautifully. The hard part about scoring L1 with an arm like you have, which is also very similar to the arm that we have, is that it doesn't like to go in the trough. But we found with the ground intake that we added that we can pick it up and dump it in the trough very fast, and it doesn't come out, it doesn't fall out, partly because the ground intake comes up higher than the 18-inch lip. And so even if it was going to bounce out, it'll hit your intake and sort of settle into the trough. So that was a really nice surprise. And I would tell, I'm going to give a ton of credit to our students on the team. This is the biggest change we've ever made to the robot between 2 regionals. The changes are enormous. So if you saw our robot in Duluth and you see it in Minneapolis, you'll be surprised at how much the changes are. But they worked their butts off. They really wanted to make some good improvements, and they were dedicated to doing it. And so hopefully the programming all gets wrapped up this week. We'll see.
And also, do you guys still have Coral Station intake, or is it strictly ground intake now?
We are strictly ground intake now.
Okay.
I have no interest. Oh, sorry.
I would love to be human player too. I don't know where we're gonna get that 3 pounds. But yeah, we had to pick one or the other, and we decided to go with ground intake.
Yeah, that's kind of a debate. I think a lot of our team is past the ground intake, but I'm still a little hung up on it. And that's like a debate we had a lot. And yeah, I did check out Wild Stings, and I was trying to do one of those, but yeah, I might still have to keep looking at it. But
you guys have 8 pounds. The other thing I will say, if you can figure out a place to put it in your robot, don't discount that pick up from the floor and throw it in L1 real quick. I think that especially when you have defense playing against you, if you can just go scoop up a few on the ground and throw them on L1 while they get distracted and go defend against someone else, and then you can get into the human player station. We talked about that after Duluth, saying, do we want to try to do ground intake, and what if it was only for L1? So I feel like so you guys are heading to champs, and I feel like that actually will be on people's scouting list. There's a real good chance at champs that if you get picked up for the playoffs, the reef's going to be full above L1. And so picking up a robot that has a good auto, has a deep climb, and can fill up L1, I feel like that's going to be a second or even a backup robot. So not to push you in one direction or the other,
Right.
But if you feel like you've got the time, it's a good exercise. Whether it goes on the robot or not, it's a great CAD exercise. It could be, you could learn a lot from it.
Mm-hmm.
Do we have a video of our L1?
Yeah, I don't know, but I don't think we do. Yeah, we figured out a sequence in order to score L1 where we like go up to the reef, we go up a certain distance, and then we shoot the coral as we're going up. So then it kind of like, like let's go like this, and then as we push it up, it falls over.
Oh, neat. So you like tipping it, you cause it to go end over end?
Yeah. So
nice.
And like, yeah, and I'd say it's been working pretty well, right? It is like a little slow to just line it up, but I mean, at that, like, our kind of thing is like, especially for 10,000 lakes, we're gonna be the only time we'll be scoring L1 is for the ranking point, and if we're going for the ranking point, we'll probably be in a lead where we have the time to score L1.
Yeah, the one thing I will say that is unproven, and for Wild Sting as well, is I don't know how well that's going to survive robot on robot contact. Right, this year's we're not getting a lot of high speed impacts this year, but still 115 pound robot running into another 115 pound robot. So it'll be interesting to see. It does make several of us very nervous that we don't have the ability to get from the human player station should we bust our ground intake. And so we're taking a gamble. The students felt like it was worth it, so we're going to do it. And we'll probably take an entire intake as backup parts, maybe, or enough of the parts that we feel like we can swap them out quickly. It's a good question. Is there a rule on backup parts now anymore? Is there no way? Because I know they got rid of the withholding limit of 30 pounds years ago, and they got rid of bag day.
The only thing is, if you bring backup parts, it can't have wheels. That was what we learned last year.
Yeah, bring a whole robot.
It can't be a robot.
Okay.
So it can be your robot without wheels.
Yeah,
So
I think there's like
modules.
Yeah, and I think it's like if it's a 1-to-1 replacement, it doesn't count against your robot weight when you weigh in. I think if you're like swapping out an A for B, if let's just say this robot on the screen right now, the algae claw swapped out for a ground intake, like fully swapped out, I think you would have to include, I could be reading the rules wrong, but I think you'd have to include that in your robot weight when you weighed in for inspection, because it's like a fundamentally different part of your robot. But if it's 1-to-1 replacements, I believe then you don't have to.
Well, you'd have to get reweighed if you had changed out the system. Yeah.
Right. Yeah.
Before you could get back out in the field. Yeah.
Yes. I had a snarky comment. I was going to say, I have no interest whatsoever in what you've changed for 10K. There's no reason why I would ask, because we won't be there with you. Or anything you've been working on since Duluth that someone with literally no interest might want to know about?
So the big thing was our intake. We noticed we got jammed up a lot with our coral intake, because originally it used to be like maybe, I wouldn't say twice the width, but it was a few more inches wider, because our original thought was that we couldn't put coral in the station and slide it around. So we thought like, okay, well, we'd like to have the coral be at one place and you could still grab it if you were like 1 or maybe even 2 slots away. But then as we got closer to comp, we were seeing, I think it was Hilltopper's video that we saw, and we saw the guy sliding the coral, and we're like, wait, you could do that? And sure enough, you can. So then as we got after the comp, we realized that our intake could be a lot more narrower, and that way it would go in faster and it wouldn't get hung up anymore. So that was the big thing. We changed the torque on our arm as well, so that we were holding algae better. And other than that, that's pretty much it. Mostly just code now.
I will share, and we mentioned this after week 1, but if you guys are going to do that trick where you insert the coral and then you grab it from on top so you can slide it, make sure your human player has gloves. Our human player got cut up pretty bad by having his hands inside all that polycarb.
Okay.
Isaac, do you have something we've been working on autos too.
Yeah, I'm trying to pull it up.
Okay. Or maybe Isaac,
while
you
he's
want to
doing
talk
that,
about Isaac? We want to talk about some of the code you've been working on besides that.
Yeah, sure. From Duluth, the biggest thing we've been working on is auto scoring. We walked into Duluth with auto rotation to whatever side of the reef, and Sam just had to manually line up with all the posts from there. And I kind of went into it on the presentation, but we retuned our drivetrain for autos, and we have a 4-piece working in the shop for whatever that's worth. So probably a 1 or a 2-piece at 10,000 or 10K. But if I can get it pulled up, we're pretty proud of it.
Yeah, you should be. That's amazing.
I don't know if other people deal with this, but it's like, I mean, we're running into stuff like, you know, like our April tags are a little, probably not mounted perfectly. They're a little bubbly, and you're just like, I mean, we got to the point where like we were hitting our 3-piece in Duluth over and over and over, and then it won't work on our field. We're like, what do we do with this now? Like, do we rebuild it? Do we move it? Do we just leave the set points and just know it misses on our shot? You know, it's kind of like, I don't know if anyone else has dealt with that, but it's like, once you've tuned it to the real field and you find yours is different, it's like.
Well, and then you know that 10K is going to have a completely different field than Duluth.
Yeah,
and
true.
So, yeah, that calibration time is really important.
are you doing? I'm not a programmer. Are you doing full disclosure? Are you doing, like, when you say set points, we're doing like kind of full field pose estimation, I believe. Is that similar thing, or am I off base completely?
Yeah, so when I say set points, we do have we use our limelight and our odometry to find out where we are on the field, and then we use profiled PID controllers, so to drive up to wherever we want on the reef.
Okay.
Initially, we thought about using path planners. New stuff this year, I forgot what it's called. But we ended up going away from that because I kept seeing threads on Chief about the last 6 inches just not quite getting you there. And so 6 inches is a lot in this game. I mean, you got to be within 2 to score.
What kind of while Isaac's working on bringing it up, what kind of prototyping did you guys do this year, as far as out of wood, only on CAD? Like, how does that go, I guess, or how did it go?
We used our laser a lot, and cut it out of hardwood. Yeah, we'd pretty much just bring something up, and like that first one, we had a coral shooter. Like, we had the original coral shooter design, and then it was very long, so then we could like bolt it in different places and see how high it needs to be up in order to reach L4. And then from there, it's kind of just like, I think we agreed that I think it was 1/2 inch of compression on the coral was enough. And then from there, it was like just always kind of like tweaking little things, like should the coral shooter be shooting from closer or more back, and what angle it needs to shoot out of. We kind of landed at 30 degrees right now, but we're looking for maybe for Worlds increasing that angle to 40, just so then we can shoot down on the reef faster. Yeah.
Isaac, are you trying to bring up a video? Are you using a Mac?
Oh, muted.
No, I'm on Windows. It's coming up right now.
Because I know that we've had people in the past who, with Macs, you have to disconnect grant permissions and then reconnect. So I just wanted to see if I could help that way.
All right. Should be coming up. My computer's fighting Advantage Scope and VS Code right now.
Is it winning or losing? Must be losing.
Yeah, it's losing.
I guess the other fun feature, while we're waiting for that, we can talk I guess I'll tell the story of this one. So I linked it here. Is intentionally or initially we said barge is just totally out of the question, and then once we had this arm that could intake algae, Sam and Isaac Sam did some number crunching, right, and said, I think in theory we can toss it in there. And me being a crabby mean mentor, like, we're not wasting our time on that. That's not going to work, you know. So Isaac cranks out some code, and they throw the first. They say, can we try it? Fine. So they're in this practice space. The first one throws 2 horizontally and breaks off one of our L4s, and then so he tweaks a couple numbers. Second one goes through, shatters a ceiling tile. I'm like, okay, I think you guys got it. Rock and roll. And so that's where that came from. Total serendipitous, like not part of our it was ruled out of the process, but kind of came for free out of luck. So I don't know.
Wow. Just
Wow.
That's awesome.
Thank you.
What are you running for Swerve?
We're running West Coast's X2, and we have them inverted. So, I don't know. They feel a lot faster than last year. We running Revs, Neo Vortexes or something. I don't know. They just feel so much faster. And I wasn't on the programming team last year, so I don't know the numbers, but just watching Sam drive around you can see the difference.
And the biggest thing too was that last year we had a lot of swerve problems. It was probably like the fault of us breaking down every other match. And this year so far our swerves have not failed on us yet.
Well, you'll be lucky you switched off of Rev because they rebuilt all of their libraries on December 15th or something like that and released it. And we have Rev Max Swerve. And it was just, according to the programmers, it was a dogfight for like until February because they didn't know what anything was. So I would say I think you made a sound decision, at least this year.
Our build students, or our primary driver requested our build students. We switched from L3s to L2s, so we gave up some top speed in favor of better acceleration. They didn't seem to think that we were ever getting to top speed, and so they wanted more acceleration out of the swerve modules. So we've made that change for North Star.
Yeah, you guys want to share what we were just having that discussion too, weren't we?
Yeah. Definitely not something we can do before 10K, but before champs, we're thinking drop the gear ratio down a little bit more, get some more acceleration out of it. Because like you said, I don't know, it's quarter field cycles, so you rarely ever hit top speed.
I think our primary driver also wanted a little bit more pushing power when someone's playing defense on him to be able to try to muscle his way into the human player station. Although now we don't need to get to the human player station, but I still think it'll be helpful for that acceleration piece. It'll be interesting. I mean, we have to redo all of our autos. We were planning on redoing all the autos anyway. Some of the students are going to try choreo now instead of Pathfinder paths. We code our autos, but we use the tools to generate the paths. So now they're starting over. I mean, literally, it's like a whole nother 6-week build season. Our students have decided they are going to try lots of different things, and they're working their butts off. I will give them that. But yeah, so now apparently we're going to do choreo. So maybe we'll have a choreo presentation to put up after we've done a Pathfinder presentation. We'll see.
What are your goals for the future? Looking ahead, 3-5 years, what are you sort of building towards?
I'm not really sure. That's kind of past my time. So, I don't know. Stone, next year you'll still be here. What are you wanting?
I don't know. I think we approach next year kind of with the same mindset we approached this year with, because again, we're losing some pretty vital parts of our team. So we're not going to be too ambitious. I think we learned our lesson in 2024. Yeah, the seniors of 2024, they all have the same message. Just keep it simple. Don't overreach. And I don't know, that's going to be my mantra for next year. Next 3 to 5 years, that doesn't incorporate me too much either. So that's more of a mentor problem.
I will say it's on the schedule to sit down and talk about it. Let's put it that way.
Okay.
Yep.
Talking about the future, what's your training process look like? How do you spend your fall, or in fall or summer and summer? How do you get your students ready to go for January, so that you can sort of had that consistency in your program?
Yeah, so like I said before, it can be a little struggle because all the students who come in here don't have that much knowledge. Usually when we're lucky, we get kids coming in from like welding or, like building background pretty much. But other than that, we kind of have to teach them how to design and how to program. Fall practices are usually building pretty much and like showing how systems work. I think this year we showed off what previous games were like and the thought process we take behind them. And I think we also just building new things as well. So then we get knowledge on new mechanisms and training younger kids on how those work. I know we're rethinking how we're teaching design, right, Sam? We kind of want to take a different approach at that, but we're still kind of thinking about exactly how we will.
Yeah, I think I don't know if we're like the best people to ask about this, honestly. As a team, we actually start generally after, like, at least historically had been, we kind of kick the season off when fall sports end. So really like the second week in November, which is very late. And I know it's very late relative to other teams. We've made it work for a while, but I think the dedicated students do a lot in the summer for sure. But it doesn't give the new kids who say, hey, I'm going to do this robotics thing second week in November, it doesn't probably set them up as well as it could. So it's a growth area, I think. I don't know.
I will say, I think with the new control hub that's coming out, it's going to make FTC so much more vital as the gateway to FRC. You can build cheap little robots using the same control hub and teach coding and all that sort of stuff. I think it's going to be a huge game changer for all of us, more than we even realize. And it's going to make FTC so much more crucial as a training ground to get people into FRC.
Sam, I wanted to share that I don't think your school not having a big technology program is really as much of a hindrance as you think it might be, because our school has 2 AP Comp Sci classes, and we teach all those kids how to program years before they get to Comp Sci. They're coming in and by the time they're able to take that Comp Sci computer programming class, they're bored as heck because they already know how to do all this stuff. And I think that's probably true for design. I think that I don't know how much CAD work our students get to do in classes, but certainly they're going to do a whole lot more in robotics as a freshman or sophomore. Freshman, I would say for sure. Maybe they can take that class as a sophomore in our high school. But I would say that even if the schools offer those high-tech type of programs, there's a better chance that they're going to learn more or learn from robotics first. So don't let that discourage you, because I suspect that it's not as big of an advantage as you think it might be.
All right.
And on the other hand, our school only has our only construction class, which could be considered trades, is theater. And, we sort of take that place of STEM curriculum, thinking about, we get all of the students who could be interested in STEM at all, right? Thinking about if they're interested in biomedical engineering, sure, you can join the robotics team. If you're interested in, electrical wiring stuff, sure, you can join the robotics team. And so thinking about, advertising yourselves not just as an engineering club, but as a STEM club, I think has worked really well for us because our school, our only advanced science classes are biology.
All right, I think we're getting to the end here. Does anybody want to wrap up with any final comments or questions?
I wanted to say thank you for sharing, and I really like the idea of having kind of the mock pit, having people practice where to find things. I think that's a wonderful idea that I'm going to pass back to 2472.
Thank you.
It's our first year doing it. It's been, yeah, it really has. I mean, we did a little last year, but this year all in, and it's been awesome. It's, yeah, the pit is so smooth. It's crazy.
That's fantastic. And I really enjoyed seeing your shop space. I think a lot of us make assumptions of what different teams has for shop space and the challenges they've had over the years. And I liked that part of this conversation as well. It also, the improved space ability access that you have gotten over the years, I think that's encouraging for all of us. And I do mean all of us who have been dealing with space issues and fighting for space within our schools. I feel like even conversations that I've had with our school of saying, hey, we need more space. And they say, well, what do other teams do? You know, that's a hard thing to respond back to because you don't really have a good idea of what other teams are doing oftentimes. All right. Well, once again, thank you very much. Big round of applause here for tonight's presenters, the MegaHertz. Really appreciate you guys putting this together. I don't know how much prep you did, but it looked like a lot, and we really appreciate it. I will once again put out another call for topics. Let me see here quick. I don't believe we have anything set up for next week or even any weeks into the future here. Nope. So everything's open. Please, if you're interested in chatting about a topic, presenting something that you've done, hosting a conversation where you just want a bunch of advice, that's totally cool too. All we need is somebody to put together some talking points and keep the conversation rolling. So please consider signing up. There's a link to sign up on every email that goes out, and you can also find the place to sign up at team2052.com/roundtable. All the links to the YouTube videos and the sign-up sheets and the mailing list sign-up and all of that are on that website. All right. Thank you, everyone. I look forward to seeing you all in the next week. Hopefully, we'll have a topic already figured out before we join the call on Sunday. Good luck to everyone who's competing.
Thank you.
Yep.
See ya.
See you all on Wednesday or Thursday.
Yep. See you there, Jeremy.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.